Our next example is still algebraic, but we throw kind of a little bit of geometry in here. We have this line segment XY. Sorry, my light is freaky flashy, so I hope we're good. Okay, we have this line segment XY. And we're told that the length of XY is 42. We can also see that XY is made up of two line segments that are connected at this point Z. So we have XZ that has a length of 3n plus 4. And let me change colors. ZY that has a length of 3n. Here, I'm gonna and with this information, we're given xy equals 42. We want to prove that n equals 5. So again, the first statement that we always make is the statement that we are given. So let me write statements. This is our reasons column. Okay, so we're given that xy equals 42. And because we're given that, that's obvious, and that's our reason is that was given to us. Someone told me. Okay, next, we notice the xz plus zy, the xz and zy are connected to make xy. We can use the segment addition postulate to say that xz plus zy equals xy. What that means is basically if I take this segment and stick it next to this segment, then the length of this whole segment is equal to the length of xz plus the length of xy. So that's the segment addition postulate. Now, we just go ahead and we throw our 3n plus 4 in here, and our 3n in here, and our 42 in here. And we're just going to go ahead and say that that's because of substitution. So we take the length of xz and we put it in there. We'll get a little more detailed on that in a minute. So we take our length of xz and we plug it in place of xz. Our length of zy and plug it in here in place of zy. Maybe it would be easier if so our length of xz is right there. Our length of zy is right here. We also took our length of xy and we plugged it in for xy. Okay. So now, we're going to do the same thing we did up here. We're just going to use our next logical step to solving for n, and that would be to distribute this 3. So because 3 times n plus 4 plus 3n equals 42, by the distributive property, we know that 3n plus 12 plus 3n also equals 42. Then we use our addition of monomials to combine like terms. So 3n plus 3n is 6n, and then this 12 just comes down. It still equals 42. Next, let's look back up at this example. So we combined like terms up here, and then our next logical step. What's the next step into solving? The next step in solving for n. We need to subtract 12 from both sides. In order to do that, we use the subtraction property of equality, which we talked about in the last slide. Okay, now how do we get n alone? We divide both sides by 6. We use the division property of equality, and we get to the point where we can see that n equals 5. I'm going to go ahead and take a picture of this page so that if you're missing any information, you can copy it on the next slide.